Okay, so our second problem is prove that if T is a full binary tree, then the number of leaves of T is one more than the number of internal vertices, which are non-leaves. So we're going to prove this result by the process of induction. So we'll start by saying the basis and of induction is where I'm going to start my induction. Let's say a binary tree consisting of a single vertex when n is 1 has one leaf and no internal vertex. Has one leaf and no internal vertex. And hence in this situation what we can say that thus the number of leaves is equal to number of internal vertex plus 1, as this one is 1, this is 0, that's 1. So basis of the induction is good. So I'm going to start with the induction hypothesis now. So we'll say for induction hypothesis, assume that for some k greater than 1 or greater or equal to 1, all full binary trees with k or fewer total number of vertices so this is what we're going to assume have one more leaf than the non-leaves. So then the internal vertices. Okay. So that's our induction hypothesis, and remember our next step is to show it that it is true for k plus 1. So we'll say now consider any full binary tree with k plus 1 many vertices and let's let TA and TB be the left and right subtrees because it's a full binary tree. Be the left and right subtrees. But as soon as we go to the subtrees, remember the total number of vertices in these subtrees is going to be strictly less than k plus 1 because at least the root is not part of these two subtrees. So both of them are going to be, the number of vertices in TA and TB are less than k plus 1. So hence I get to say that, thus, if IA and IB be the number of internal vertices in TA and TB respectively, we get that JA, so this is the number of leaves, equal to IA plus 1 and JB is equal to IB plus 1, where JA, JB are number of leaves in TA and TB respectively. That's pretty simple to understand, and it is following just by the induction hypothesis, as both TA and TB has the total number of vertices strictly less than k plus 1. Okay, so what we get to say? We get to say thus the total number of leaves total number of leaves is as simple as JA, the number of leaves in A, plus the total number of leaves in TB, which is JB, and this is going to be equal to, by the work we have done, is IA plus 1 plus IB plus 1. So that's the total number of leaves. So this number, IE plus IB, if you think carefully, IA is the total number of internal vertices in TA. IB is the total number of internal vertices in TB. But there is one other vertex, and that is the root. So I can go ahead and say that IA stands for the total number of internal vertices in TA. IB stands for the total number of internal vertices in TB. And this one stands for, this plus one stands for the root. So together, they are all the internal vertices in the tree. So this is internal vertices plus 1. And isn't that exactly what we wanted to show? We wanted to show that at the k plus 1th level, so the tree that has k plus 1 many leaves, you have k plus 1 many vertices, the total number of leaves is exactly one more than the internal vertices. So by induction hypothesis, for any full binary tree, the number of leaves in the binary tree is exactly one more than the number of internal vertices. So we'll go ahead and answer one more question in this section. And this is drawing a binary tree with 7 vertices. First, we want to draw it in a way so that it has only one leaf. So what we do, start with the vertex 1. Go to the left, call it 2. You can keep going to the left, but say for a change, I go to the right. So the first level, you did not have any right tree. Now you do not have any left tree. Let's put left tree without any right tree. Then put right tree without any left tree. And left again, no right. And then right, no left. So what is the vertex of this binary tree? These are 1, 2, 3, 4, 5, and 6, and 7. Remember, the only leaf is 7. So I have now found a binary tree with 7 vertices and only one leaf. The second question is asking me to find the binary tree with 7 vertices and as many leaves as possible. Remember, you will get a full binary tree with the maximum number of leaves. So I will do the same thing. 1, I will have 2 children of 1 and call them 2 and 3. And both 2 and 3, I will give them 2 children each, say 4 and 5, and 3 will have children 6 and 7. So this is the situation with 7 vertices where we have 4 leaves, and that's the maximum number of leaves possible in a binary tree. Which answers our question, and we're going to stop this lecture here. And this is the end of Module 7, our discussion about tree. Next time in our video, we will start talking about Module 8, which is going to talk about Boolean algebra and a little more about binary system.